Automatic sprinkler systems remain the most reliable form of fixed fire protection available today. The National Fire Protection Association has never recorded a multiple death fire in a completely sprinklered building in which the system was operating properly. In this program, you will see various types of automatic sprinkler systems and how to operate the components of a sprinkler system. The training objectives are: 1. To describe the sources of water supply for sprinkler systems. 2. To show various types of sprinkler systems. 3. To demonstrate how sprinklers work and how to stop the flow when necessary. And 4. To demonstrate how to operate each of the components of an automatic sprinkler system. Every sprinkler system should have a water supply with enough volume, pressure, and reliability to protect the building. However, the water supply for sprinkler systems is designed to supply only a part of the entire system at a time. This is called the design area. In a situation involving a large fire or a break in the pipe, the sprinkler system will need an outside source of water and pressure to do the job effectively. A minimum water supply must be able to deliver the required volume of water to the highest sprinkler in a building at a residual pressure of 15 pounds per square inch or 100 kilopascals. A connection to a public water system that has adequate volume, pressure, and reliability is a good source of water for automatic sprinklers. A gravity tank of the proper size also makes a reliable primary water supply source. In order to give the minimum required pressure, the bottom of the tank should be at least 35 feet above the highest sprinkler in the building. Pressure tanks are another source of water supply, and they are used in connection with the secondary supply. Pressure tanks are normally located on the top floor or on the roof of the building. This type of tank is filled 2/3 full of water, and it carries an air pressure of at least 75 pounds per square inch. If a secondary water supply is needed, a fire pump that takes suction from a static source, such as a large reservoir, can be used. Additional water and pressure can be provided by a pumper that is connected to the fire department sprinkler connection. As water flows into the system from the fire department connection, it first passes through a check valve. This valve prevents water from the sprinkler system from flowing back into the fire department connection. Different types of occupancies require different types of automatic sprinkler systems. There are 5 main types of sprinkler systems: wet pipe, dry pipe, pre-action, deluge, and residential systems. A wet pipe system is used in locations where the temperature does not drop below 40 degrees Fahrenheit. It is connected to the water supply and contains water under pressure at all times. This allows an activated sprinkler to immediately discharge water on the fire and set off an alarm. Wet pipe systems usually have an alarm check valve installed in the main riser. To shut down the system, turn off the main water control valve and open the main drain. A pressure gauge on the riser should indicate when there is no longer any water pressure in the system. A wet pipe system may have a device known as a retard chamber in the alarm check valve. The retard chamber reduces false alarms by catching excess water that may go through the alarm valve during brief surges in water pressure. Dry pipe systems are used in areas where the temperature may go below 40 degrees Fahrenheit. The system's pipes are filled with pressurized air instead of water. When a sprinkler head activates, the air is released first. Then a dry pipe valve opens to let water flow into the system. Dry pipe valves have a larger surface area on the air side of the valve, so that a small amount of air pressure will hold back a large amount of water pressure. Normally, the air pressure gauge should read substantially lower than the water pressure gauge. If the two gauges read the same, this system has been tripped and water has entered the pipes. The air pressure for a dry system may come from either a plant air service or from an air compressor and tank used exclusively for the sprinkler system. In a large dry pipe system, it may take several minutes for all of the air to be expelled from the pipes. This may cause a delay in the water reaching the sprinkler heads, allowing the fire to spread. Systems with a water capacity of over 500 gallons or 2,000 liters are required to have a quick opening device to help speed the release of water to the fire. A pre-action sprinkler system is a dry system with a deluge-type valve, fire detection devices, and closed sprinklers. This type of system is used in areas where water damage must be prevented, even if a pipe breaks. The system will not discharge water into the piping unless a heat or smoke detection system is actuated. When the detection devices are actuated, the deluge valve opens and water flows into the system. An alarm sounds a warning prior to the opening of the sprinklers. A deluge sprinkler system is used to protect extra hazardous areas. This type of system has open sprinklers and a deluge valve. It is designed to discharge water onto the entire protected area at once. Sprinklers in a deluge system do not have heat-responsive elements, so a separate detection system is necessary. This detection system is connected to a tripping device that activates the flow of water to the sprinklers. Residential sprinkler systems protect lives and property in single and two-family homes. They are designed to prevent total fire involvement and to allow the residents a chance to escape. These systems may be wet pipe or dry pipe systems and always used fast response sprinklers. Residential sprinkler systems must have a pressure gauge, flow detector, and draining and testing capabilities. They can either be connected directly to the city water supply or be tied into the home's domestic water system. A control valve is needed in either case to allow the water supply to be shut off. Residential sprinkler systems operate the same way as other wet or dry systems. Automatic sprinkler protection consists of a series of sprinklers arranged so that the system will automatically distribute water directly to the fire. Sprinklers discharge water after the release of a cap or plug that is activated by some heat-responsive element. Think of an automatic sprinkler as a fixed spray nozzle that is operated individually by a thermal detector. All sprinklers have a frame that is screwed into the sprinkler piping. Sprinklers are kept in a closed position by various means. Four of the most commonly used release mechanisms are fusible links, glass bulbs, chemical pellets, and quick response mechanisms that fuse or open in response to heat. In a fusible link sprinkler, the water is held back by two levers pressing against a cap over the sprinkler opening. A fusible link holds the levers together until the link is melted during a fire. Then the water pushes the levers in the cap out of the way and strikes the deflector on the end of the frame. The deflector converts the standard half-inch water stream into a wider spray. Some sprinklers use a small bulb filled with liquid and an air bubble to hold the opening shut. Heat from the fire expands the liquid until the bubble is absorbed into the liquid. This increases the internal pressure until the bulb shatters, releasing the valve cap. The breaking temperature is regulated by the amount of liquid and the size of the bubble in the bulb. Another device is the chemical pellet, A pellet of solder, when placed under compression within a small cylinder, will melt at a predetermined temperature. This allows a plunger to move down and release the valve cap parts. The quick response mechanism was specifically developed for life safety purposes. This specially designed fusible link sprinkler has a larger surface area to collect the heat generated by a fire. This results in a faster opening of the sprinkler and quicker extinguishment of the fire. Occasionally, you may need to stop the flow of water from a single sprinkler that has been activated. This may be necessary even after the main water control valve has been closed, because the residual water in the system will continue to drain through the open sprinkler. To stop the flow of water, insert small wooden wedges between the discharge opening and the deflector. Tap them together by hand until the flow is stopped. Commercially made stoppers are also available that can be inserted to plug the opening. Closing a sprinkler while water is flowing takes some practice, and all firefighters should learn to be proficient in this skill. In order to properly operate an automatic sprinkler system, it is important to understand the system's components. The system starts with a feeder main into the sprinkler valve. The riser is the vertical piping to which the sprinkler valve, one-way check valve, fire department connection, alarm valve, main drain, and other components are attached. The feed main is the pipe connecting the riser to the cross mains. The cross mains directly service a number of branch lines on which the sprinklers are installed. Cross mains extend past the last branch lines and are capped to facilitate flushing. System piping decreases in size from the riser outward. The entire system is supported by hangers and clamps. All pipes in a dry system are pitched to help drain the system back toward the main drain. There are three basic designs for sprinkler heads: pendant, upright, and sidewall. The most common type is the pendant sprinkler, which extends down from the underside of the piping. This sprinkler sprays a stream of water downward into a deflector that breaks the stream into a circle. The upright sprinkler sits on top of the piping. It sprays water into a solid deflector that breaks it up into a circle that is redirected toward the floor. The upright standard sprinkler cannot be inverted for use in the hanging or pendant position, because the spray of water would be directed toward the ceiling. The sidewall sprinkler extends from the side of a pipe and is used in small rooms where the branch line runs along a wall. It has a special deflector that creates a fan-shaped pattern of water. Special sprinklers with corrosive-resistant coatings should be installed in areas where moisture, chemical, or other corrosive vapors exist. Without this special coating, the operational parts of the sprinkler will corrode and may become inoperable in a very short time. Every sprinkler system is equipped with a main water control